Which one of the following expressions has an even integer value for all integers a? And so first we need to understand, to answer this question, what is an integer? An integer is just a whole number. So numbers like 2 or 3 or 5,162, these are all integers because they are whole numbers. A number that's not an integer is, for instance, 3.3, right? Because this has a decimal point, that means that it is not an integer. What is an even integer? Well, that's a number that can be divided by 2 and still be an integer. So here, 2 is even, 4, 6, those numbers are all even. But a number that's not even, for instance, is 5. 5 is not an even number. And specifically, if I divide any of these numbers by 2, I always get an integer value. So let's divide 2 divide 2 by 2 and you get 1, divide 4 by 2 and you get 2, divide 6 by 2 and you get 3 integers, just like we want. If we divide 5 by 2, we get a number 2.5, not an integer, and that's how we know that a number is actually not even. Well, the same logic applies to equations. We can actually just divide an equation by 2, and this can help us determine if it's always produces an integer value, and therefore if it's always even. So let's try this with the first one. 8a plus 2ac, and let's go ahead and divide this entire equation by 2. And if we do that, we divide 8a by 2, we get 4a. And if we divide 2a plus c by 2, we just get a times c. This is a little basic algebra here. And this equation will always produce a whole number. As long as a and c are whole numbers, this will produce a whole number. So let's imagine, say the value of a was 2, it would be 4 times 2 plus 2, and let's say the value of c was 3. Now we have 8 plus 6, this is equal to 14. A nice whole number. We expect it to never have some decimal running off. Now, it turns out that's the correct answer then. We just figured it out. When we divide this by 2, it always produces a whole number. The correct answer is F. But before we move on, let's just show why these other answers are not correct, again, by dividing by 2. So let's take G. We have 3a plus 3c, and here we're going to try to determine if it's even by dividing by 2. Well, 3a divided by 2 is 1.5a, and 3c divided by 2 is 1.5 times c. And now we can figure out values of a and c that are whole numbers that still result in an uneven result. So let's say we set a equal to, let's say we set a equal to 1, so then be 1.5 times 1. And let's say we set c equal to another integer 2. We'd have 1.5 times 2. Then we have 1.5 plus 3, and this is equal to 4.5, not a whole number. And the basic reason is that these decimal numbers can end up producing decimal numbers in our output. And this is not a correct answer. And if you go through each one of these and try to divide it by 2, you'll notice very quickly that F is the only one that doesn't include decimal coefficients after dividing by 2. So in the same way we can check numbers for being even by dividing by 2, we can also check entire expressions. And that's pretty cool.